Algebra 2, target 34. I can fit a set of data to a normal curve. Today in class we did an activity where we saw that most of the data in life falls within a set of range and follows a certain pattern. And that pattern we called the bell curve, also referred to as a normal curve. And we talked about a standard deviation, that's your average distance away from the average, and that most data falls within 68% of the average. That'd be one standard deviation above or one standard deviation below. That's where 68% of your data falls. When you spread it out, 2 standard deviations away from the average, you're going to get 95% of your data. And you keep getting less and less data added on as you go further out because it's rarer and rarer to have kind of an outlier. If you look at it one-sided, this table kind of follows the one-sided. This table's on page 757 in your book. You're going to want to reference this table as we work through these activities and as you work through any assignments that you are given in class. So let's use this table. A normal distribution has an average, a mean, of x and a standard deviation of theta. I'm not sure how to pronounce that. We'll call it Omicron. For a randomly selected x value from the distribution, find the probability that the average minus 2 standard deviations is less than x is less than the average. So here we're saying that the value we pick is between the average and 2 standard deviations below. Well, on our table, here is our average. Here is 2 standard deviations below. We just got to see how much of the graph we cut off. And this part is 13.5 and this part is 34. So the probability that a randomly selected value will be 2 standard deviations below the average or the average is 47.5%, or 0.475 as they do it. So the probability of point is between the average and 2 standard deviations below the average is 47.5%. Example 2. Pause, try this, and we'll go through it together. The blood cholesterol readings for a group of women are normally distributed with a mean or average of 172 milligrams per DL, not sure what that is, and a standard deviation of 14 milligrams per deciliter maybe. About what percent of the women have readings between 158 and 186? Well, if you take a look, right, the average is 172. You take our 172 minus 158. That's 14. The standard deviation is 14. So 158 is 1 standard deviation below. 186 minus 172. That's 14. 1 standard deviation above. So we're within 1 standard deviation on A. So within 1 standard deviation, that's 68% of the women. 68% of the women have a blood pressure between 158 and 186 because that's within 1 standard deviation of the average. Readings higher than 200 are considered undesirable. What percent of the readings are undesirable? Well, 200 minus 172, that is 28. That's 2 standard deviations above. What percent of the population is 2 standard deviations above? That would be 2 standard deviations above 2 standard deviations. That'd be 2.35 and 0.15. So that would be 2.5% of the population have an undesirable blood cholesterol. Try these, pause, we'll go through them. What is the probability a randomly selected point is less than the average? Well, the average means middle. What's the probability you're less than the average? Roughly, well, 50%. 50% will be above, 50% will be below. Probability of being below is 50%. And here we're between the average and 2 standard deviations above the average. Right, here's our average. Here's 2 standard deviations, these 2 sections, 34 and 13.5. 47.5%. Right here, the probability are less than 3 standard deviations below the average. This section over here is 0.15%. And that brings us to our next topic, and that is a z-score. For a standard normal distribution, instead of saying so many standard deviations above, so many standard deviations below, we just say it's a z-score. So what we do, we'll find your average and your standard deviations. We'll talk about calculating those in a little bit. What we do is we take the amount we're looking at and we subtract our average, and then divide by our standard deviations. That tells us our z-score, which is how many standard deviations above or below the normal we are, or the mean we are. And this chart kind of breaks down the percentages above that many standard deviation a little bit more. So to read this, let's say you have a z-score of, let's say, 1.2. If your z-score is 1.2, you'll find 1.2. Your z-score tells us that 0.86, your value is higher than 0.86 of the population, or higher than 86% of the population. So that's what a z-score does, and that's how this table goes. This table you're going to need a lot too. This is from page 759 of the textbook. All right, so let's look at this table and talk about seals. Scientists conducted aerial surveys of a seal sanctuary and recorded the number of seals they observed during each survey. The numbers of seals observed were normally distributed with a mean of 73 and a standard deviation of 14.1. Find the probability that at most 50 seals were observed during the survey. So what we need to do first is we need to figure out the z-score. What is the z-score for 50? So we'll take 50, we'll subtract the average, and divide by the standard deviation. 50 minus the average, divide by the standard deviation, punch that into your calculator, you get negative 1.63. And on this chart, negative 1.6, it says 0.0548. That means the probability that at most 50 seals were observed is 5.48 or 5.5%. Not very likely that they saw only 50 seals. All right, take a look at this question. Given the percent of the area under the normal curve represented by the shaded region. We got the normal curve. We want to know what is less than 3 standard deviations below and more than 3 standard deviations above the average. Well, if we take a look, this one helps a lot. This region right here is 99.7% of the graph. And we're looking for the region outside of that. Well, that would be 0.3%. A normal distribution has a mean of 27 and a standard deviation of 5. Find the probability that a randomly selected value from the distribution is between 12 and 27. Well, 27 minus 12, that's 15. 15 divided by the standard deviation is 3. We're 3 standard deviations below the average is 12. 27 is the average. So between 3 below and the average is this much of the graph. All right, so that's 34 plus 13.5 plus 2.35. That works out to be 49.85%. 49.85% of the values will be between 12 and 27. What percent will be between 17 and 37? Well, 27 minus 17, that's 10, which is 2 below. Z-score of -2. 37 is a z-score of +2. What's between -2 and +2? We'll look on this one. -2 is here, +2 is here. We can see that 95% of the data falls there in that range. All right, and one final question. The annual per person consumption of apples is normally distributed with a mean of 16 pounds and a standard deviation of 4 pounds. Find the z-score for an annual consumption of 22 pounds. So we need to take 22 minus the average and divide it by the standard deviation. 22 minus 16 is 6 over 4. Our z-score is 1.5, which means here's 1.5, matches up right there, 0.9332, which means this person that eats 22 pounds of apple per year is eating more apples than 93.32% of the population. And that is fitting a set of data to a normal curve using the standard deviation and the mean.